Hey, what's up, guys? This is Dr. Vivek Palipuram bringing you the next lecturette in ECPE 127. So let's solve this problem, which I like to call as the limits with relation problem, because the region of non-zero probability has an explicit relation between x and y in this manner. X plus y is less than or equal to 1. And that's why I like to call this problem as limits with some relationship. So for this problem, what we'll do is, or what I'll do is for you, I'll solve problem A or part A, finding the constant C, and I'm going to solve part C for you. What is the probability that X is less than or equal to Y? Parts B and D are your in-class problems for Friday. Or rather, they are the participation problem for Friday's class. So you need to solve them by 2 p.m. on Friday. Solve by 2 p.m. So this coming Friday, it's 3rd of April. So for 3rd April, Friday's class, you need to solve part B and part D. So you need to find the marginal PDFs fx and fy and tell me whether they're independent or not. And you need to find the probability that x plus y is less than or equal to 1/2. For you, I'll focus on finding the value of constant C and the probability that x is less than or equal to y. So your joint PDF of x comma y is equal to constant C in this region. And it is equal to 0 otherwise. And I need to find the value of constant C first. So it's always useful for us to draw the region of non-zero probability. The region of non-zero probability is as follows. X is greater than or equal to 0, y is greater than or equal to 0, which tells you that this is going to be in the very first quadrant. But you have this additional relationship that x plus y is less than or equal to 1. So to identify this relationship, first I'll plot the equality relation, which is x plus y is equal to 1. So first I'll plot that. Now the region either above this line or below this line is going to correspond to x plus y is less than or equal to 1. I like to use an empirical method where I just randomly select a point. So let's say that this is point 0, 0. So it satisfies this condition that x plus y is less than or equal to 1. So this shaded region is the region of non-zero probability where both x and y are positive and x plus y is less than or equal to 1. To find this constant C, I'm going to integrate the joint PDF over the region of non-zero probability. Whatever I get, that will be equal to 1. So I'll use this equation to find the value of constant C. So let's find out the limits of integration here. So for any value x in this region, y varies from 0 until this point where y is equal to 1 minus x due to this relationship that x plus y is equal to 1 on that line. So that's the extent to which y varies in this region from 0 to 1 minus x, but no more. Y is always less than or equal to 1 minus x. Once I have integrated y out, x varies from 0 till x is equal to 1 in this region. So this point is 1, 0. This point is 0, 1. So x varies from 0 till x equal to 1 in this region. So the limits of outer integration will be from 0 to 1, and this should give me a value equal to 1. When I solve this integral, I get this. C is a constant. First, I integrate with respect to y. When I integrate a constant with respect to y, I get y, and the limits are from 0 to 1 minus x. So that will give me 1 minus x dx. Next, I have x minus x squared over 2, 0 to 1. That should give me 1. So when I plug in a 1, I get 1/2. When I plug in a 0, everything goes to 0. Therefore, C is equal to 2 in this case. So that's the value of the constant C. C is equal to 2. Now let's solve part B here. Or rather part D. I'm going to solve part D for you, whereas I'm going to solve part C for you. Parts B and D are for you to solve and until Friday by 2 p.m. So I need to find the probability that x is less than or equal to y. So let me perform it here. Probability that x is less than or equal to y. My apologies for the background. That's my little kid who is being a fussy eater, and as a result, she's unhappy because there are some vegetables on her plate. But oh yeah, so let's focus on this problem here. I need to find the probability that x is less than or equal to y. F of xy is equal to 2, the constant that I found in this region of non-zero probability. It's equal to 0 otherwise. So this is the region of non-zero probability. So let's plot the region of non-zero probability first as your very first step. So the region of non-zero probability I already obtained from the previous step, and that is this one right here. So this is the region of non-zero probability. The region A is x is less than or equal to y. Now to find this region x is less than or equal to y, first I'll plot the equality relationship, which is x is equal to y. So let's plot the equality relationship now. The equality relationship is this one right here. X is equal to y. Now, either the region above this line or below this line is going to correspond to x is less than or equal to y. This point right here, where x is equal to 0 and y equal to 1, satisfies this relationship that x is less than or equal to y. And therefore, this point is definitely a member of this region, x is less than or equal to y. This point clearly does not satisfy that condition. So this one right here is NZ intersection A. I need to double integrate my joint PDF or that region NZ intersection A to find the probability of A, which is probability that x is less than or equal to y. So let's double integrate the joint PDF over that region. Now carefully observe how I'm going to evaluate the limits of integration. It's a very important step in this case. This intersection point where x is equal to y and x plus y is equal to 1, let's find that out, what this point is. When x is equal to y, 2x is equal to 1, that means x is equal to 1/2. And y is also equal to 1/2. So this point right here is 1/2 comma 1/2. So x in this region can at most go to 1/2 but no farther. We'll remember this fact. Now to get the limits of the inner integral with respect to y, here's how I can do it. For any value of x, y varies from this point where it is equal to x until this point where y is equal to 1 minus x. So y varies from x till 1 minus x. So that's the limit of my inner integral. For my outer integral now with respect to x, once I have integrated y out, x varies from 0 till x is equal to 1/2 and no more, right? So in this triangular region, after I have integrated y out, after I have disregarded y, x varies from 0 till 1/2. So from 0 to 1/2. So by this point, you would have gotten 90% of your credit. Now, let's work for the remaining 10%. So when I evaluate this integral, I get to y, and the limits are from x to 1 minus x. When I plug in and 1 minus x, I get 1 minus x. When I plug in an x, I get negative x. So this gives me 0 to 1/2, 1 minus 2x dx. So when I solve this integral, I get x minus x squared, 0 to 1/2. And the limits are 0 to 1/2. So I get 1/2 minus 1/4, giving me 2 times 1/4, which is equal to 1/2. So that is the probability that x is less than or equal to 1/2. All right. Now, before I let you guys go, let me ask you this question. What is the probability that x is greater than y? Okay, so I think it's a good point to stop this lecturette right here. As I mentioned before, parts B, entire part B, which includes finding the marginal PDFs of X and Y and telling whether or not they're independent or not. And this probability, X plus Y is less than or equal to 1/2, is due April the 3rd for Friday's class by 2 p.m. So please make sure that you review these videos much ahead of your Friday's class so that you have enough time to solve these two parts. Okay, I think it's a good time to stop this video.